Before a Tesla car ever moves under its own power, before software updates or autonomous features, it is born inside a place that does not feel like a traditional factory. It feels more like a system that never stops calculating. From the outside, the Gigafactory looks immense. Steel, glass, and geometry stretching across the landscape. But scale is not what defines it. Intelligence does. Inside, the first thing you notice is the rhythm. Machines move with certainty. Robotic arms swing, pause, and resume with mechanical confidence. Conveyors glide silently. There is no shouting, no chaos, no improvisation. Everything is already decided. Production inside a Tesla Gigafactory begins with data. Screens across the facility display live information, output rates, machine health, material flow, energy usage. This data is not just observed. It is acted upon in real time. The factory is not reacting. It is anticipating. Aluminum coils arrive first. Massive rolls of metal are fed into stamping presses that operate with extreme force. Panels are shaped in seconds, doors, roofs, side structures. Sensors monitor thickness and consistency as each piece is formed. If a deviation appears, the system adjusts automatically. Or stops. Stopping here is not failure. It is correction. Freshly stamped panels move into robotic welding zones where hundreds of machines operate simultaneously. Sparks flash briefly as joints form, but the choreography is precise. Robots never rush. They repeat the same motion thousands of times, exactly as programmed. Lasers scan the chassis after welding. Alignment is verified instantly. A misaligned frame does not continue forward. There is no fixing later. This is one of Tesla's core manufacturing philosophies. Correct early or don't continue at all. But Tesla does not stop at traditional car manufacturing. Nearby, giant machines known as gigapresses dominate the space. These machines do something radically different. Instead of assembling dozens of stamped parts, they cast large sections of the car's structure as single pieces. Molten aluminum pours into massive molds under extreme pressure. In moments, a complex structural component is formed strong, lightweight, and consistent. Cooling systems stabilize the casting carefully. Thermal cameras monitor temperature distribution to prevent internal stress. Once cooled, robotic milling systems refine the surface. Laser grids map dimensions down to fractions of a millimeter. This single-piece approach removes complexity. Fewer parts, fewer welds, fewer opportunities for error. Efficiency is not just speed here. It is simplification. While the body structure takes shape, another critical system is being built elsewhere in the factory. The battery. Rows of battery cells are assembled into modules by robotic systems that never touch a cell directly. Precision matters. Each cell must be positioned perfectly to ensure thermal balance and long-term performance. Modules are combined into battery packs, sealed, and tested under controlled conditions. Electrical integrity, thermal stability, structural strength. The battery is not an accessory. It is the foundation. In Tesla's newer designs, the battery pack becomes part of the vehicle structure. Front and rear castings are joined directly to it, creating a rigid, integrated platform. This changes everything. The car is no longer built around the powertrain. It is built as the powertrain. As the structure completes, autonomous systems take over material movement. Automated guided vehicles glide silently across the floor, delivering components exactly when needed. There are no piles of inventory waiting around. The factory does not store time. It consumes it efficiently. Wiring systems are routed with minimal complexity. Tesla designs reduce cable length wherever possible. Less wire means less weight. Less weight means more efficiency. Interiors arrive next. Seats, dashboards, and massive touchscreens are installed by robotic arms that align components with digital precision. The interior looks simple, but simplicity here is intentional. Every element exists because it had to. Glass roofs are installed using suction systems that lower panels into place without vibration. Doors mount and align automatically. Flush handles are tested for movement and response. Throughout this process, software is already flowing into the vehicle. Before the car ever moves, it is alive with code. Operating systems are uploaded. Control units synchronize. Sensors wake up. Cameras calibrate. The vehicle begins learning its own identity. Tesla cars are not finished when they are assembled. They are finished when their systems agree with each other. As the vehicle lowers onto the factory floor for the first time, it looks complete. Wheels attach. Torque tools confirm exact specifications. The car begins to resemble what customers recognize. But Tesla does not trust appearances. Trust must be earned. And that comes next. Thumbs up if you're enjoying this inside look at how Tesla builds cars differently from every other manufacturer. Tap the like button. When a Tesla vehicle rolls forward from the assembly line, it is already different from any traditional car. Not because of how it looks, but because of what it knows. At this stage inside the Gigafactory, the focus shifts away from metal and toward intelligence. The vehicle may be physically complete, but its most important systems are still being awakened. Tesla does not treat software as an accessory added at the end. Software is the nervous system. As the car enters the next zone, it connects wirelessly to factory networks. Massive servers begin communicating with the vehicle instantly. Control units synchronize. Firmware versions are verified. Any mismatch triggers an automatic correction. The car does not leave this area until every system agrees. Screens illuminate across the interior for the first time. The central touchscreen powers on. Diagnostic menus appear briefly, visible only to technicians and automated systems. The car is asked a simple question: "Are you ready?" Before the vehicle ever moves, hundreds of checks happen in seconds. Battery management systems test charge stability. Thermal systems simulate temperature changes. Inverters and motors receive calibration signals. Everything responds. If a response is slow, delayed, or inconsistent, the system flags it immediately. Unlike traditional factories where testing follows a fixed checklist, Tesla's testing adapts. The factory learns from previous vehicles and adjusts thresholds dynamically. If a pattern appears, the system tightens requirements. This is not static quality control. It is living validation. The vehicle now moves into sensor calibration. Cameras, radar systems, where applicable, ultrasonic sensors and internal monitoring systems must all align perfectly. Calibration targets line the walls and floor. The car observes them while stationary, then while moving slowly. Millimeters matter here. A slight misalignment could affect perception later on the road. Tesla does not allow approximations. Adjustments happen automatically, or the car returns to calibration until perfection is achieved. Next comes autonomous testing. Inside controlled lanes within the factory, the vehicle begins to move on its own. It accelerates gently. Brakes engage. Steering inputs are measured. The car parks itself, repositions, and stops. No driver is inside. The factory watches closely. Every movement generates data. Steering smoothness, brake response, motor noise, energy draw, all compared against ideal models. This is where Tesla's approach becomes clear. The factory is not just building cars. It is training them. As the vehicle proceeds, it enters environmental simulation zones. Temperature chambers replicate extreme heat and cold. Thermal systems react accordingly. Battery cooling adjusts. Cabin climate responds. Next comes the rain test. High-pressure water sprays from every angle. Roof, doors, glass seams, underbody. The simulation is harsher than most real-world conditions. Inside the cabin, moisture sensors remain alert. If water enters, the car fails immediately. But Tesla's testing does not stop with physical conditions. Software stress testing begins. The vehicle's systems are pushed simultaneously. Navigation, media, autopilot processing, climate control, all run together. The goal is not comfort, it is resilience. Can the car think clearly under load? Over-the-air update simulations follow. The vehicle receives mock updates, installs them, reboots, and confirms integrity. This ensures that future updates will be seamless for customers. Tesla understands that the car's life does not end at delivery. It evolves. The vehicle now enters final visual inspection. Automated vision systems scan every exterior surface. Paint finish, panel gaps, reflections, microscopic imperfections are highlighted instantly. Interior cameras inspect stitching, alignment, and cleanliness. Human inspectors remain involved, but their role is focused. They verify what machines flag, not what machines miss. This partnership between human judgment and machine precision defines the Gigafactory. No system works alone. Once the vehicle passes inspection, it is prepared for logistics. Protective films are applied automatically. Wheels are covered, seats wrapped. The goal is preservation, not presentation. But before shipment, one final step remains. Identity. The car is assigned its digital identity. VIN confirmation, regional configuration, charging standards, regulatory compliance. From this moment, the car is no longer anonymous. It belongs somewhere. Destinations appear on logistics dashboards. Some vehicles will travel by truck, others by rail, many by ship. Routing is optimized automatically based on demand, distance, and delivery timelines. As the vehicle rolls toward outbound lanes, it does so quietly. There is no celebration, no final announcement. The factory has already moved on, because the Gigafactory does not pause to admire what it creates. It measures what it learns, and everything it learns improves the next vehicle. Bell if you want more deep, inside the factory stories like this. Subscribe. The final session reveals how Tesla's system keeps learning even after delivery. When a Tesla vehicle leaves the Gigafactory, the factory does not forget it. In fact, the relationship has only just begun. Traditional manufacturing treats delivery as the end of the process. Once the car reaches the customer, the factory moves on. Tesla does the opposite. The moment a vehicle enters the real world, it becomes part of a global feedback system. Inside Tesla's operations centers, live data streams flow continuously. Vehicles across continents report performance metrics, software behavior, energy efficiency, and system health. This information feeds directly back into manufacturing, design, and software teams. The car is no longer just a product. It is a sensor. As finished vehicles move through distribution hubs, they undergo final preparations. Charging levels are optimized. Software versions are verified once more. Protective films are removed just before delivery. Logistics remains automated. Routes adjust dynamically. Delays are predicted before they occur. Inventory is minimized without risking availability. This efficiency is not just operational. It is philosophical. Tesla's factories are designed to waste nothing. Energy systems balance loads using on-site batteries and renewable sources. Solar arrays feed power directly into production lines. Excess energy is stored and reused. Water used in manufacturing is filtered and cycled repeatedly. Materials from rejected components are recovered and reintegrated. Even heat generated by machines is captured and redirected. Sustainability here is not branding. It is math. As vehicles reach customers, the feedback loop accelerates. Driving data improves autonomous systems. Real-world scenarios train neural networks faster than simulations alone ever could. Software updates roll out quietly, often unnoticed by owners. Vehicles gain features, improve efficiency, or refine behavior while parked overnight. This is unprecedented. The car improves after purchase. Inside the factory, this data reshapes everything. Assembly processes evolve. Materials change. Software and hardware co-design becomes tighter with every iteration. Factories themselves learn. Robots adjust movements based on wear patterns. Maintenance occurs before failure. Production schedules regenerate automatically. This is manufacturing without downtime. As night falls, the Gigafactory does not sleep. Lighting dims. Machines clean and recalibrate. Systems run self-checks. AI models retrain using the day's data. By morning, production resumes, smarter than before. There are no banners announcing improvement. No speeches. No pauses. Just progress. Tesla's approach challenges the idea of what a factory is. It is not a building. It is a network, a loop, a system that extends beyond walls and borders. Every car contributes to the next one. Every mile driven improves the system. This is why Tesla vehicles feel different. Not perfect, but evolving. The factory did not finish when the car was delivered. It expanded, and it continues to think quietly every second. Speech Balloon, now tell me in the comments, which fully automated factory or future tech brand should we go inside next?